Hello, everyone. Good morning, dear author and invited guest. Welcome to Technical Session 2C. Myself, Karthik Bharadwaj, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you all in the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being held or organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th Feb 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you all will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations, and each presenter will be given a time of 12 minutes. 2 minutes for question answer round, and at 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remark. If you have any query or update, then you can write it to me in the chat box. Before getting started, I would like to introduce you with our today's session chair, Dr. Jagdish C. Bansal, Associate Professor, South Asia University, Delhi, India. Dr. Jagdish C. Bansal is an Associate Professor at South Asia University, New Delhi, and visiting faculty at Maths and Computer Science, Liverpool Hope University, UK. His primary area of interest is swarm intelligence and nature-inspired optimization techniques. He has published more than 70 research papers in various international journals and conferences. He has worked with Indian Air Forces and Liverpool Hope University, UK for various research projects. Sir, we want you to motivate our participants.
Thank you, Mr. Karthik, for the opportunity to be here as a session chair in this session. I'm in contact with the GR Foundation long back from more than 6-7 years, and I have seen the progress. I have seen the quality of the conferences that the foundation is involved. ICICT is the one flagship conference of this, and I am really happy to be part of this as a session chair. I really congratulate all the authors that their paper has been accepted to this very reputed conference. I am actually, I was supposed to attend it physically there in London, but due to my other commitments, I could not. Thank you so much. Best of luck for all the participants for their presentations. Have a great learning. Thank you.
Thank you, sir. Let's moving towards our first presentation. For the first presentation, I would like to call Kibashni Mudle for the paper title, A Systematic Literature Review on the Impact of the COVID-19 Pandemic on Digital Access and the Digital Divide in South African Higher Education. Ma'am, you can proceed with your presentation.
Thank you, Karthik. Would you like me to put my video on as well? Okay, good morning, everyone. My research is titled A Systematic Literature Review on the Impact of the COVID-19 Pandemic on Digital Access and Digital Divide in South African Higher Education. I am Dr. Kibashni Mudle, and a student, an honors student of mine had engaged in this research, and her name is Neo. I will be presenting on behalf of both of us. So before I can begin with the actual discussion of this research, I just want to touch on two aspects: digital access and digital divide. So when I talk about digital access throughout this presentation, I'm referring to students being able to have access to digital technologies like computers, tablets, any digital device that will assist them in engaging in the teaching and learning process. Digital divide, I'm referring to students that may be disadvantaged in accessing the same benefits of using these digital technologies, such as not having internet access, maybe having a device that's outdated. So just keep in mind those two terms as I go through the presentation. So the COVID-19 pandemic forced many people to go online, including students. So there was about 1.4 billion students who had to now transform their teaching and learning process from being face-to-face to now being online. And many schools and academic institutions had to be closed, and academics engaged in the learning activities and the facilitation of the course using online platforms. Now, what did this mean for students that did not have access to these digital devices and did not have access to the benefits that most students have access to? So with the COVID-19 pandemic, as I said, they were forced to go online. And South Africa being a country that there are a lot of inequalities where not every student has access to devices, not every student has access to the resources like the data, Wi-Fi connectivity. So many of the students were left behind when it came to engaging in the academic program online. And South Africa, prior to the pandemic, had a lot of inequalities when it came to students accessing material online. So before the pandemic, this was already a problem. And during the pandemic, it just became worse. So this research looked at, what problems the pandemic how did the pandemic actually make the situation worse for students that came from a disadvantaged background. So many students found it a challenge to just get access to devices to be able to log into these online classes. They had challenges in completing whatever tasks the lecturer had given to them. So there were a lot of challenges that these students in South Africa experienced. There were a lot of efforts by government and academic institutions to be able to assist these students, whether it was to give them access to devices, help them with data. There were plans in place, but they were not good enough. So prior to the pandemic, the government was assisting these students, and many of these students rely heavily on the government to be able to fund them when it came to higher education. So when the pandemic hit, things just became worse because students relied on Wi-Fi connectivity on campus. They relied on the labs, the computer labs, and they were now not able to get access to those resources. So the background of this research was to look at what was the situation, current situation of students engaging in the academic program during face-to-face lectures. So what challenges did they experience then? And how did these challenges actually become more of a problem during the pandemic? So about 2.3 million students were enrolled in higher education in South Africa when the pandemic hit. And many of these students came from disadvantaged backgrounds, whether it was them being from rural areas, living in townships, not coming from the same economic background where salaries were not the same. The location that they lived in didn't even have connectivity, didn't have internet connectivity. They couldn't even connect their cell phones to classes because the connectivity, the cell phone connectivity in those areas were not even good enough. So they relied heavily on government funds prior to the pandemic. And although there are educational policies in place that say that the use of tablets and computers are very beneficial in education, we need to also look at how beneficial is this if students can't even access the basic requirements. So the objective was to understand the consequences of the digital divide. We know in South Africa that a digital divide does exist. What are the different measures that are being put in place to overcome this digital divide? And when the pandemic hit, things became worse. So what were now government and academic institutions doing to now alleviate these issues and to make it easier for the students that came from these disadvantaged backgrounds? Through analysis, so we use systematic literature review, where we looked at various literature to see what does it say about the current situation when it came to the digital divide in South Africa. What were the issues that arise as a result of the pandemic? And what were students now doing to be able to access these resources? Because we know prior to the pandemic, they had resources on campus. Now with the pandemic hitting and we had to now be isolated and the academic institutions had to shut down, what were students now doing to be able to gain access to their teaching and learning process? So we had to look at factors that contributed to the heightened digital access gap among students. We are familiar that there is a problem in South Africa, and what were the contributing factors during the pandemic that actually resulted in students experiencing far worse issues in gaining access to education, which is supposed to be available to every student. So a lot of explorations needed to be done in terms of looking at what is the challenges that were experienced, what would be the potential solutions. As I mentioned, academic institutions did try to give students tablets, digital tablets. They did also tried to give them data. So in that sense, they did try, but it wasn't good enough. So we needed to look at recommendations for future pandemics, and what would government be able to then do, or academic institutions, to make it easier for the students from disadvantaged backgrounds. We also looked at how this research can contribute to existing knowledge, and we know what the problem currently is, and we just want to see how this study is going to assist. When I was going through the various literature reviews, we noticed that there wasn't much research done with regard to South Africa. So this research in particular will add to that body of knowledge so that people can now better understand the South African, the challenges that students experience and how the pandemic actually made things worse for them. Okay, so with education, we need to make sure that there are, equality when it comes to education, no matter which background you come from. Every student is able to experience and the same, learning that takes place online, to ensure that students are able to engage in the online platform, to be able to contribute, participate in that session. The main research question that came about in this study was, how has the COVID-19 pandemic amplified the existing digital divide with South African higher education students from marginalized backgrounds? So we're looking at students specifically that are disadvantaged when it comes to resources, when it comes to just connecting their devices. Students couldn't even use their cell phone devices because it was outdated. It didn't have certain features to allow them to engage in these online activities. So yes, the government did try their best to provide students with the resources, but if you're living in a rural area, in a township where you don't even have basic necessities like electricity, I mean, how are they able to connect their devices? How are they able to charge their devices? I don't know if you're familiar with load shedding, but we currently experience load shedding in South Africa. So during every 4 hours or every 2 hours, a certain area in South Africa doesn't have electricity. So like from 6 o'clock today till 8 o'clock in the night, I won't have electricity. That's because we don't have enough electricity in South Africa. So that's also another thing to look at is, yes, we provide these resources to students, but how are they able to connect their device to an electricity supply? So it's far beyond the pandemic that's an issue. It's just the basic necessities we can't even provide to students. So after doing the gathering of literature and processing of this data, a thematic analysis was used, where we went through understanding what are the challenges, understanding the digital divide, understanding what students have access to, what they don't have access to, in reference to students from disadvantaged backgrounds. So coding was done where we use an inductive approach, where we brainstormed, came up with ideas, looked at how certain policies can be changed in South Africa to accommodate students. Sorry, Karthik, I'm just checking how many more minutes do I have?
You're left with 2 minutes.
2 minutes, okay. So the themes that emerged from the gathering of this data was, we looked at some stuff like the financial and income disparities. We looked at environmental and situational barriers. We looked at academic performance, because many of the students that were disadvantaged and couldn't engage in these online platforms to continue with their education, either dropped off from their studies, they experienced difficulties in their careers, and it was a huge problem overall. So the research questions that we looked at were what were the pre-existing digital access gap in order to understand how the pandemic either made things worse or better. And in this case, it made it worse. We also looked at social economic factors, looking at where students are located. Are they living in townships? Are they living in disadvantaged backgrounds? What problems do they currently experience? And how will the pandemic now just, blow things out of proportion? Okay, we also looked at lack of access to digital devices and how this would affect them during the pandemic. And we looked at what strategies and interventions the government or academic institutions can put in place to assist these students. Point number 3 is NEFSAS. This is the financial body that students get funding from for their studies. And during the pandemic, a lot of students required this funding. Okay, so the pandemic just shifted the education to an online platform, and many students were forced to, whether they liked it or not, they had to jump on board with this idea. And many of them were disadvantaged because of the various reasons I explained. And we just need to see how, as a country, we can assist these students, whether there's a pandemic or not. We did realize that during a pandemic, things just got worse. And as a country, we need to see how we can assist these students in general during a pandemic and also prior to a pandemic, because these students are, they have the rights to equal education. Thank you.
Thank you, ma'am. Dr. Sir, do you have any questions? I think so. You don't have any questions. Let's move towards the next presentation. For the next presentation, I would like to call all parents for the paper title, An Automated and Goal-Oriented Clustering Procedure. Sir, you can proceed with the presentation.
Thank you very much. So I will share my screen. And we can begin. So hello everyone, and I'm happy to be here today and present to you the automated and goal-oriented clustering procedure, a research and a new algorithm that made by me, and my two colleagues, Oded and Michal Koren. So we are going to start with a short introduction to understand the field, and then we will drill down to the problem. So this research is about two main fields, where the first one is clustering. So basically clustering is just uncover similarities inside data without a predefined knowledge. This is in contrast to traditional ML algorithm that I want to learn something that I know in advance. And there is many challenges in clustering that we will soon talk about. And the second field that this research is aimed to is the automated machine learning, which very great leap in the technology and the algorithms, that if I just examine the traditional machine learning workflow, so the programmer or the researcher should pre-process the data and train and choose any model and evaluate the result. In AutoML fashion, we just combine those three components into one black box that automated the process. So this research aimed to bind between these two fields. And for the better understanding of the clustering procedure, we just cover the four main categories of clustering technique that already exist today. The first one, and very popular, is the partitioning, which uses iteration and divide the dataset into clusters of similar items. A very popular algorithm is k-means. We have the hierarchical combination, which can split the data top down or merge the data bottom up in recursive way. Here we can use agglomerative or birch or any other algorithm. The third group we have is density-based, which instead of divide the data into K clusters, it search for densities inside the data set and then define it as a cluster like DBScan or optics. And the last one is the graph-based method that aim to search a connected component inside the graph. And here we have the spectral clustering or the affinity propagation. Of course, this is just a sample of clustering technique, but those are the most popular that they used in the days. So what is the problem that we want or we aim to solve? First, how can I choose the right clustering technique for my dataset? Because let's take a case of I used k-means and want to divide the dataset into two groups. So it can be, since k-means it's, I'm sorry, since to determine the cluster is NP-hard problem, it can be just give us two different results. And of course, for the meaning, there is different meaning in the obtained clusters. And I don't know what is it's the better one for my dataset. The second problem is how to choose the number of clusters. As I said, we know that is NP-hard problem. So if I will take an example dataset and then evaluate 4 clusters or 6 clusters or 8, I get different results with different insights and information inside the clusters. And the last challenge that is also very, very challenging to overcome about is what happened in multidimensional data sets. Mostly all of the data sets are multidimensional these days when the information it's grow exponentially. But we also know that in high-level dimension, the similarity metrics that the clustering use lost their meaning and the data become mostly sparse. Like most of the data becomes zeros or something like that. So we want to solve exactly this problem. So how can I choose the number of clusters or what is the best clustering technique for me? So the algorithm is called automated clustering. And before we will present the algorithm, we just need to cover the performance metric of clustering. Since clustering is belong to the unsupervised learning, we don't know how to examine the result and to know how good was the clusters that I obtained. So in this research, we use 4 performance metrics. The first one is the silhouette, which aim to describe the density inside the clusters and the distance between the clusters. The second one is the Kalinski-Harbert score, which aim to describe the variance ratio between the clusters. Low variance ratio means more dense clusters. And the additional two, and the additional 2 performance metrics use the parameters of distance inside cluster from the extreme points in the clusters, and also examining the distance between 2 clusters. And we use here the Dune index and the DBI to the Dune for minimizing the distance here, and the DBI to maximize the distance between 2 clusters and to get more meaningful ideas. So how it works, our algorithm? The user can input dataset and his goal, and the goal can be many, many things, like I want to find the clustering technique that maximize the completeness of the clusters, or maybe I want to minimize the distance inside or between clusters. I want to maximize silhouette. There are many, many goals that I can choose. And then our algorithm compare 8 different clustering techniques and choose the best one based on threshold learning. Threshold learning means it's like a grid search that we defined in advance multiple parameters that the algorithm search, and last it returns the dataset and the clusters. So here in the threshold learning, I think that this is the most important part. So let's see it in a graphical. So the user input data and a goal. Here also the user required to enter a threshold, like what do you want me to search, the improvement that you want me to search. You want me that all the performance metric will be improved by 10%, by 20, by 30, and other. And when the algorithm starts comparing different clustering technique, it stores the values of the hyperparameters and the performance metrics for each iteration. For example, in k-means, it's examine k equal 2, k equal 3, k equal 4, and etc. And then in case it appears to be 2 iterations that the improvement between them just passed the threshold, I keep and save the clustering technique and the parameters. Otherwise, I just drop the technique. And that way, the algorithm iterates over and over all the grid parameters that defined and can find multiple clustering technique that fit into a single dataset and changing according to the needs. So until now, it's a little bit algorithmic and very general. Here in the empirical study, we can just see the result and analyze the procedure. So we tested the procedure over 4 datasets. We pre-processing the data by normalizing and standard EDA exploratory data analysis. We use predefined threshold of 10% between 2 iterations. And to examine the clusters obtained by each technique, we use dimensionality reduction using PCA.
Sorry to interrupt you, sir. You have 2 minutes to conclude.
Okay, thank you. Exactly on time. So as you can see, if we choose different goals, we can get different clustering technique according to the dataset that we compare. But let's see it on the density estimation. Here is an example of the such dataset that in case that I want to maximize its homogeneity, look here, the clusters have very homogeneity in the density estimation. But in case that I want to maximize the Kalinski-Harbor score, like the variance ratio, so optics just raise a better result. And also that if we compare our result to traditional k-means that mostly use, it can be seen that most of the time we just extremely expand and improve the silhouette score, except of one case. So just for conclusion, we can say that if the silhouette has extremely high score, we can conclude that more dense and well-separated clusters are obtained. And we also can say that different clustering technique can just explore different conclusions than necessary. And last and not least is if we use multiple performance metrics combined together in some method, it can be just explore more information than a single metric. And you can see also here in the improvement percentage of the silhouette. So thank you very much for listening.
Thank you, sir. Now I request Amit, sir, do you have any questions? So, do you have any questions? I think the sir is not having any questions. Let's move forward to the next presentation. So for the next presentation, I would like to call Hector Rafael Morano for the paper title, Effect of Using Computational Fluid Dynamics Stimulation on Student Learning During a Mechanical Engineering Course. Sir, you can proceed with your presentation.
Okay, hi, hello everyone. I'm going to share my screen. Okay,
Yes, sir, it is visible.
okay. Well, as I said before, I'm Hector Morano. I work for Tecnológico de Monterrey, campus state of Mexico. And the title of this presentation is The Effects of Using Computational Fluid Dynamics Simulations on Student Learning During a Mechanical Engineering Course. So here is the agenda I'm going to follow. First, I will give a brief background just to put you in context. Then I will describe the objectives of this work. Subsequently, I will mention the methodology that we use. And finally, I will share the conclusions and future work. So nowadays, universities look to attract students' attention to improve their learning. So we can use different strategies. For example, we can use activities related to everyday problems, or we can perform some digital platforms to perform quizzes. In other cases, we can use some types of video games. And in our case, we are going to use virtual simulations. So we decided to test these virtual simulations with a course called Design of Thermofluidic Systems. And some topics of this course contain these three: viscous flow in pipes, aerodynamics, and equations of fluid flow and heat. So we want to use CFD simulations, employ CFD software tool applications. So now we can enlist the objectives of this work. The main objective of this work is to know the effect of learning when students were taught a course with CFD simulations. So we use 4 groups to evaluate these CFD simulations. And also we employ some surveys to apply to students just to know their perception about the course. And finally, we ask students to give us some comments just to know their opinions about the course. So here we have the 6 steps of the methodology. The first one, we have to identify in which model we are going to use this CFD simulations. We selected the module 2, which refers to aerodynamics. The second step was to generate the exercises that we use in every topic. The third step was to decide or to identify which software application we want to use. In this case, we decided to use the ANSYS Fluent software applications, since professor and students can download it for free, so they can practice everywhere. The fourth step was to create the evaluations that we are going to use for every task. And the fifth step was to create the 5-question survey. We decided to use a brief survey just because we have seen that students don't like to answer this type of surveys. So that's why we decided to use a brief one. And in the sixth step, we decided to have the same professor for the 4 courses. So here in table 1, we can see some information about the 4 courses. In the first 2 courses, we didn't use the CFD simulations, just in the last 2. And we can see the number of students in each group. In table 2, we can see the 5 questions of our survey. The answers can obtain value from 0 to 10, with 0 being the minimum evaluation. Now here we can see some example of the different exercises that we use. For example, in the figure 1 and figure 2, we use these 2 exercises just to students get familiar with the software applications. So for example, in the first exercise, students have to obtain the hydrostatic pressure in a container. In the second exercise, they have to model the pipe, this type of pipe, and then they have to obtain the pressure distribution. In the third exercise, they have to model the heat exchanger, and then they have to obtain the flow lines through the heat exchanger. And finally, in the last exercise, they have to evaluate the aerodynamic profile in a basic wind tunnel. So here we can see from figure 5 to figure 8 the results of the surveys. So we use the mean, and the standard deviation of each question. So we can see the value, the results of each questions are really good. They are high values. We can see from 10 to 9.17. So their results were really good. But well, we can focus on the question 3 in the 4 groups. They have the same behavior. And these questions, if we go back, the third questions refer to that the students feel kind of freedom to express their opinions. So they are comfortable with the professor to express their ideas. And for example, in question 2, we can see almost the same behavior in the 4 groups. Is the lowest value, the lowest evaluation. But if we see the numbers, we can say again that the values are really good, from 9.67 and 9.88. So they are highest value. But well, we can see the question, so that the students feel that the exercises didn't were very challenging. And to summarize this survey, we can see the results of question 5. Also, they are good values. But in the last 2 groups, where we use the CFD simulations, the values were 9.88 and 9.83. And this question is related with the general opinion of the course. So they feel that in the last 2 courses, with the CFD simulations, they feel a kind of improvement. And the last figure, in figure 9, we have the student grades of the 4 groups. So again, we can start noticing that in the first 2 groups, the student grades were lowest than in the last 2 groups. So we could say that, or we can think that the CFD simulations improve the result of this survey. Okay, and here we can see the comments of the students at the end of the semester. We can notice that they didn't mention something related with the CFD simulation. They emphasize with the attitude of the professor. We can see that they detected that the professor was very patient to resolve doubts and the way he managed the course. But we cannot notice something related with the CFD simulations. Okay, so now we can list the conclusions that we find. So it is observed that using CFD simulation in class increases the learning of topics related to fluid dynamics. Using software applications to perform simulations attract student attentions and improve motivations to solve more complex problems in fluid mechanics. The use of digital simulation tools in university classes is well accepted by mechanical engineering students who are attracted to tests with different boundary conditions and geometries. And finally, currently it is possible to use CFD software applications aimed to academia, which can be downloaded and installed for free on professors' and students' personal computers. And for future work, we detected the following task. We have to explore the use of some exercises in transient regimen or with phase changes in simulated fluid, including setting up activities based on standards such as NFPA 52 or CSA to define the dimensions of fuel volume locations using results from CFD simulations. But the problem here is that probably we are going to spend some time to solve this type of problem, probably 20 minutes or more hours. And of course, these tasks must be implemented in later courses. So that's it. Thank you very much.
Thank you, sir. Sir, do you have any questions?
Thank you, Dr. Hector, first of all, for your presentation. I think it was a very specific presentation and specifically for the young researchers to make them understand that how this aerodynamics is being used and how some fluid dynamics can be used to enhance the thought process of the youth or the students, what you are talking about. But a quick question that you have been using a data set where the survey would have been floated to get the results. Right. So that data set includes it's only one institution, or you have circulated among, because the variety of data sets should be a priority in this case to have the actual results.
Yes, we use 4 groups in different years. And just in the last 2 years, in the last 2 courses, we use CFD simulations. In the first 2 groups, we didn't use the CFD simulations just to have just to be able to compare the results between these 4 groups.
Okay. And is there any other methodology which is also being into practice by some other researchers to analyze this kind of results or something?
No, we just use in this case, in this time, in this research, to compare this to this to use CFD simulations with a normal course. This is the first time, well, in the last 2 courses, this was the first time we use CFD simulations for this type of courses.
Okay, thank you so much.
You're welcome.
Thank you, sir. Now we're moving towards the next presentation, For the next presentation, I would like to call Tariq Khan for the paper title Enhancing KPI Forecasting Through Regression Algorithm Using Historical Data. Sir, you can proceed with your presentation.
Hello.
Yes, sir, you are audible.
Hello, can you hear me? Hello, everyone. I'm Tariq, and I'm doing PhD from University of Polytechnic Delhi Market. And today I'm going to present my current research paper. It's called Enhancing KPI Forecasting Through Regression Algorithm Using Historical Data. As you know, key performance indicators are a important tool for monitoring and development of success of interactive industries. Key performance indicators used to measure the performance of organization and industries. So accurate forecasting for key performance indicator currently is critical for organization success in today's dynamic business landscape. And KPIs serve informed decision making, providing valuable insight into perform the strategic planning. Traditional forecasting such as trend analysis, extrapolation often struggle capturing complexity of modern business environment. Machine learning regression offer a promising alternative for the KPI forecasting. Our research aims to experimentally evaluate the performance and effectiveness of various machine learning regression algorithms in predicting KPIs. We conducted our evaluation of 3 different cell datasets and accessed the result using 4 evaluation criteria. Our finding will empower the organization to make data-driven decision, enhancing their forecasting capability and driving organizational growth. Our problem statement was to challenges of traditional forecasting method. Traditional methods such as trend analysis and extrapolation often fail to capture complex dynamic. Traditional method often fail to capture the intricate pattern and relationship within the business data. And this method often rely on simplistic assumption of linear relationship, which may not be reflect the true nature of business. The limitation of traditional method leads inaccurate prediction that can have significant negative consequences for businesses. Need of machine learning algorithm can effectively address these challenges by analyzing large data set. Machine learning algorithm can effectively process large amount of data, extracting valuable insight, and traditional method cannot. And machine learning can identify the intricate pattern relationship within data, enabling more accurate, reliable prediction. And it's also can provide a more precise and trustworthy forecasting compared to traditional method and reduce risk accurate decision. And it's also enhance the resource management because machine learning can optimize the resource allocation by identifying the pattern data and predicting demand fluctuation. And it also can find the potential challenges, adding strategic decision making. And it's also machine learning can provide available insight to inform strategic planning decision making process. Our research objective was to use several model of machine learning. We use 7 techniques: random forest, XGBoost, decision tree, linear regression, support vector, neural network, and multi-horizon quantile recurrent forecaster. And our evaluation criteria was to use 4 performance error metric that is called mean absolute error, mean square error, root mean square error, and R square error. And the comparative analysis was to compare the result of use 3 data set and compare the result with all these algorithms. Our contribution was in this study to enhance the KPI prediction using machine learning algorithm. Here, as I said, we compared 7 algorithms, 7 techniques, and then evaluation criteria was to use metrics, MAE, MSE, RMSE, and R square. This is a common execution methodology of KPI forecasting based on our machine learning algorithms. As you can see, first of all, we take the data and we try to find a relevant KPI collected. Then we try to process the extraction of pre-processing where a specific KPI is selected, and then we have to clean and normalize and suitable for analysis. Then data is split into 2 sets. And then algorithm are trained for training set. Finally, our model used to feature from testing set the generate predicting for corresponding KPI values. Data set we use in research are Roseman Store, Supermarket 1, 2, which are publicly available online. And pre-processing ensure the quality of prepared data set effect for effective modeling, handling missing values, and remove the outliner, transfer more variable, and remove the useful data that we don't need. And then the evaluation criteria was, as I said, we use 4 metrics. And if the value of MA, MSE, or RMSE are lower, accuracy, the accuracy is greater. Where R square value is lower, it means higher, then it means the accuracy is higher. So we use 4 metrics here. And this is are some result that we get from our these 7 algorithm. As you can see, MHQRF have a lower MAE, MSE, and RMSE, and higher R square. So these have all 7 algorithms. The MHQRF performance is higher as compared to these all 7 algorithms. And here we also try to visualize our result in a graphical form. And you can see here also the MHQRF have a better performance as compared to other algorithm that we use, and have a high performance in all 3 data set. And our conclusion in future work, as you can see, MHQRF is a superior KPI forecasting techniques compared to other traditional machine learning algorithm. But as you can see, decision tree is not a reliable KPI forecasting techniques and can lead to inaccurate prediction. In future, we are going to use deep learning for KPI forecasting and should be further explored in future. And we are also try to explore further data set for more comprehensive result. And we will try to develop framework for selecting most appropriate machine learning algorithm for a specific KPI forecasting. Thank you.
Sir, do you have any questions? I think so, sir is not having any questions. So let's move forward towards the next presentation. For the next presentation, I would like to call Naomi Meblikani for the paper title Risk and Safety-Based Behavioral Adaptation Towards Automated Vehicles, Emerging Advances, Effect, Challenges, and Techniques. Ma'am, you can proceed with your presentation. I think so ma'am is not being here due to some network issues. Let's move towards the next presentation. For the next presentation, I would like to call Muhyiddin Jaradi for the paper title Using Digital Twins for Effective Energy and Performance Optimization of Buildings. Sir, you can proceed with your presentation.
Yes, hello everyone. Thank you very much. Can you hear me?
Yes, sir, you are audible to us.
Yeah, thank you very much. I'm just going to share my screen. Yes, can you see my screen now?
Yes, sir, it is visible to us.
Thank you, everyone. Thank you very much. And this is Muhyiddin Jaradi. I'm an associate professor at the University of Southern Denmark. And today I'm going to talk about our research in terms of using digital twins for effective energy retrofitting and performance optimizations of buildings. And I will just basically start through outline. We'll introduce this concept. We will say why buildings, why it's actually interesting to work on buildings, and then talking a bit on digital twins for building applications, and finally some preliminary implementations that we have carried out. Just a bit on where I'm coming from. So I am a leader of Smart Building Energy Application Group at the Center for Energy Informatics at University of Southern Denmark here. And we actually research ICT solutions for different applications. One of them is building energy applications. We are a multidisciplinary center having software engineers, mechanical engineers, control engineers, and also economists and business staff. So we have a more or less large array of collaborators from industry, from hospitals, national organizations, technical institutes, and so on. So why buildings? We have heard today many different presentations and different aspects, but for instance, why we need to concentrate and investigate buildings? First of all, the majority of research that has been presented in the last 20 years has actually demonstrated that we can save up to 30% on energy bill in buildings or building applications just by implementing some very simple measures and straightforward measures. And for non-residential buildings, energy cost is majorly or potentially the second largest cost after staff cost. So it makes sense to optimize that. And everyone is talking about energy consumption in different domains, but also in buildings. And we need to stress here that we are all not only interested in energy consumption, but also in indoor quality and indoor thermal comfort. And there are many different ways or different lines to investigate, including major hidden costs of performance gap, maintenance, management in buildings, and so on. And finally, buildings is basically or are where we spend the majority of our time. So that's basically the trigger why we need to have better building energy performance. Okay, so I always like to share this screen basically when I'm actually providing the background for our research. And what we can see here on the y-axis is basically the primary energy consumption of building. And on the x-axis, we see the building regulations in Denmark. And if you look at the year 61, the building regulation set a frame of around 400 kilowatt hour per meter square per year. That's basically what you are allowed to consume if you're building a building in that year or in that basically sort of buildings or sort of years. And then this number has actually almost halved in 79, and now you are only allowed to consume 200 kilowatt hour per meter square per year. And today we are talking about 15 to 20 kilowatt hour per meter square per year. So there's this dramatic decrease from 400 to 20 kilowatt hour per meter square per year. And considering that the majority of our buildings in Denmark, but also around Europe and generally in the world, basically belong to this year's spanning before 79 or before 80. And now you can consider how much is the improvement potential for those buildings' performance. And going more into detail in terms of digitalization. So of course, everyone is talking about digitalization. Today, we have heard a lot of presentations talking about using data analytics and digital solutions. And the building sector is not really a different perspective here. So also in buildings, people are trying, or everyone is trying in this sector to digitalize, automate, and optimize processes. And of course, the aim is still the aim that we have built our research on and our practical applications. It's improving energy efficiency, it's improving security, and improving comfort of buildings. But now we're doing this in a more digitalized way, in a more automated way, in a more smart way in that aspect. And in this regard, one of our lines of research is developing digital twins. This is a project that I'm going to concentrate on today in my speech. And this is basically called Danner Twin, a digital twin solution for energy retrofit optimization over the life cycle of the building. And this aims to decarbonize the Danish building stock. In addition to SDU Energy Informatics, we have Rimoni, that's a sensing and data analytics company. And we have one of the municipalities in Denmark, Aarhus, is a partner as well. And the project is supported by EUDP. So the project is running now, and it's basically in the second year. But the background and the initiative for this project was the EU condition of energy retrofits. So based on a lot of research and a lot of different studies in the recent 10 to 15 years, it is very much demonstrated that the rate of energy retrofit in Europe is less than 1% of the building stock per year. And that's why the EU has launched the Innovation Wave for Europe that aim to retrofit and to renovate 35 million building units by 2030. And that's a huge number of buildings. And to do that, you need an upscaled, an adaptive and automated way or automated approach to do that. In Denmark, for example, the existing buildings are around 17 or 97% of the building block, and 75% of these buildings date back to 1980. And obviously, the building envelope, the energy systems, all the different services in the building are more or less outdated if we talk about them as the current status that we design building today. This project aimed to accelerate the retrofitting. So people has been doing retrofitting for some time now and for a long time. And the aim here is to upscale this and to, at the same time, optimize the process. So not only upscale and do retrofits as fast as possible, but also in an optimized way. And the whole aim is to digitalize the stuff by using data and using data as a hub and the service for that aspect. When we're talking about digital twin, of course, there is a lot of definition of digital twins for us, for the building aspect. The digital twin is made up of three main components. A physical building, that's the real building that you have in principle. And then we try to establish a virtual twin of the building, another virtual building using software, models, different platforms, or so on. And then there is data. That's basically the connection and the integration between the physical and the virtual building. So data is going to be collected from the actual real building. It's going to be processed, analyzed, evaluated, and then decisions are going to be made by the virtual building, and the loop goes on to manage the real building. And this is basically how we depict actually a digital twin for the building application. So our proposed twin here is going to store, integrate, manage data first, then using this data-based analytics to optimize the energy retrofitting and simulate different scenarios, then trying before or after retrofitting the building to commission that and to make sure that everything is in order, and finally to establish some live decision-making approach based on a certain performance optimization principle. And this is a very simplified illustration. Of course, I won't go into every single detail, but if you're interested, of course, you would read that in the paper. But the whole aim is that we are setting a lot of sensors in the building, and those sensors are clamp-on sensors, so you don't have to do drills or changes in terms of the systems. It's just a clamp-on that you can actually sense temperature, CO2, so indoor environment, but also electricity consumption, heating consumption, and so on in different levels. After that, we are going to establish this as a platform of data, and then using different analytics and algorithms to analyze data and come up with an optimized approach to retrofit the energy performance on different levels, to commission and retro-commission this, and then finally to establish the optimization and management approach. This is how basically the connection would basically be established between the physical digital twin and the data. And as I said, data is the communication aspect between both. But most importantly for us, of course, is the back end of this. So there's a lot of calculations happening using models, and the models that we use here are more like called component models. So what we see here, for example, is a space connected with different systems, energy systems, technical systems, with fans, cooling coils, dampers, different stuff of systems. And our aim is to establish different component models for each of these components, and then to call up those components whenever we have an actual system in that perspective. And as you see, the models are not really sophisticated. They are gray box. So part of that is basically physical, and the other part is data enriched and data calibrated. And then I'm just going to show some preliminary implementations. As I said, the project is running on, and now we are in field scale demonstration. But this is a case that we started in. This is our lab case. It's an office building at the University of Southern Denmark. And we actually demonstrated the data-driven approach for a couple of services. The first one is continuous commissioning of the domestic hot water system in the building. And then the second one is energy retrofit scenarios evaluation and assessment. So two of the services that we look forward that our twin would deliver in real life application. And just to share like one diagram showing the implementation of the continuous commissioning of the domestic hot water system. That's over 30 days. What you see here in blue is the actual energy performance or consumption of this domestic hot water system. In orange, it's the predicted performance by our platform. And in green is the performance gap. So basically that's the difference between our predictions on a live perspective and the actual consumption or the actual performance of this domestic hot water system. And as you see around day 17 or 18, there is basically a gap that starts to build up, and the gap is increasing for a certain time. And that basically our platform would deliver an alarm there that there is something going wrong. It could simply be that the models are not able to capture the dynamics. That's, of course, one of the possibilities. And in this case, we have a recalibration process. But in this case, for example, the technical services guys would go there and check what's happening in the building. And in this case, it was a controller fault in the storage tank. And this basically leads to all of these different dynamic gap between our predictions and the actual system. So we are trying to commission this on a live perspective, but also on a moving window, trying basically to as fast as possible to capture problems and capture faults and then alarm those to save, of course, resources and cost in that aspect. The second implementation is scenarios improvement, or sorry, improvement scenarios evaluation. And in this case, we actually defined around 19 improvements. I won't go into details on each of these, but generally it's physical building improvements like changing windows, insulating walls, control improvements like installing daylight sensors, peer sensors, controlling the ventilation using CO2, and also modifying some components like installing LED lights, for example. So some of the very well-known implementations in retrofitting in
Sorry
Denmark,
to
but
interrupt,
also
sir,
around the EU. Yes,
but you
sorry.
have 2 minutes to conclude.
Good. I still have only one more slide. Thank you. So the heating energy savings that we see here is basically showing the implementation of each of these. And then it's, for example, very clear that some of those different improvements can lead to major savings. Others are more or less having a trade-off. For example, adaptive control of heating system can save around 18%, where, for example, insulating wall can save 9%. And this is, of course, from a technical perspective. We can do a similar evaluation in terms of electrical savings. And here, for example, we see that replacing LED lights in this building or replacing lights with LED could lead, for example, to around 12% savings, but also controlling the ventilation system using CO2 sensors can save around 15 to 16%. And a very important note here that generally the approach, the general standard approach is to go for standard insulating of walls, roofs, windows, and so on. And here we can see that smart control of the building and optimization of performance is as good as changing the physical envelope. So I'm not saying that we shouldn't improve the physical envelope, but it's also demonstrated that combining this with a good control of systems can yield very good output and improvement. Finally, just some conclusions. So as I just presented here, we actually are proposing a digital twin that can optimize and then can actually serve as a backup for decision-making retrofitting of buildings, but also operational optimization. The twin is based on data collected from different innovative sensors, clamp-on sensors. So we actually install the sensors for a couple of weeks in the building. We get data and we do our evaluation based on that. And then I demonstrated here the very brief implementation of continuous commissioning and retrofit evaluations. And as I said, the solution is being revisited and upgraded now by actual demonstration in 2 real cases here in Denmark. And the plan also is to implement it for other actual case. And one of the major points to finish is to combine the technical analysis that I have just shown here with some sort of economic analysis as well. So to do techno-economic analysis, because some of the, of course, optimization strategies or some of the optimization measures would be more optimized from technical perspective rather than from economic perspective. Thank you very much, and I will be happy to answer any questions you have.
Thank you,
Dr.
sir.
Jarvi, thank you so very much. This was a very fantastic presentation, and I think what you have implemented over your university with respect to the consumptions and then what analysis you have done according to the sensor-based systems among twin users, what you say, it's really fantastic. Just have quick one question that is it only applicable towards the building energies? Or means the energies of the buildings, just the physical buildings, or there are any other use cases of this whole process?
Yeah, thank you very much, Amit. I mean, it's basically, as I said, we research ICT solutions, and one of them is digital twins applications. And this is basically a very specific application, and that's buildings. In other projects, we also target district heating. In other projects, we target greenhouse, like agricultural greenhouses. So very similar approaches we use in different applications that needs to be upgraded based on the actual system, of course. But of course, this is showing it for buildings. We can apply it for different aspects. It's more about the twinning of this. And I think maybe that the key here is data. Whenever you are able to get good data, validated data, and data that you need to build good models in the back end, then you can actually apply it to different applications.
Thank you. Thank you so much.
Thank you.
Thank you, sir. Now we are moving toward the closing remark. I sincerely thank all the authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8th version of the conference. We will be happy to have you in the 10th version in 2025. All the presenters will be getting their digital certificates through email within 2 working days. Further, while the papers have already forwarded to the Springer, the publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I also thank our session chair, Dr. Jagdish, for chairing the session. This is a token of appreciation from ICICT 2024 and Global Knowledge Research Foundation and partners. Sir, kindly acknowledge our participants. I think the sir is facing some network issue. So I also want to extend my gratitude towards our next session chair, Dr. Amit Joshi, for sharing the session. Sir, your presence was valuable for us. Kindly acknowledge our participants. I think the sir is also facing some network issue. It's okay. I request everyone to turn on their cameras for a quick snapshot. It was a wonderful session. Stay connected, stay safe, take care. Thank you, everyone.
Thank you.
Thank you. Bye.